Alright, brother, here's your 300 amp power supply. I forgot and already put the screws on the case. I should have did a quick recording of the inside before I did, but I took quite a few pictures. I'll just add them into the video. I ain't taking this top back off. That's a lot of screws, man. I got it all bolted down and ready to roll. So there's your voltmeter, on and off switch. Okay, you know, we're rolling with the external amperage meter. Okay, I've got that in the box for you right there, and it plugs into the back here. That's it right there, plugging in. Okay, because we'd worked out putting an amperage meter on it after I'd got the case painted. I didn't even want to attempt to put a hole saw on this box, man. Especially this candy paint. This paint is expensive. If I mess something up, oh my goodness, that would hurt my pocket to get another case painted. And so yeah, man, this right here is now the biggest supply I've ever put together. I just don't get a lot of power supply requests. Got it floating. Well, I wouldn't say floating, but right there about 14.8, 14.9. I did that because I know once it does drop, I was kind of wanting it to be around 14.5. Pretty much, you know, the same voltage your vehicle will be running at. Because usually it'll drop about a half a volt under a good load. Okay, got the load tester right here. There's your beautiful baby right there. 2x12 regulated AB biased. Driver and final switchable, so it is staged. That's what the two switches are in the front, but I'll show that to you here in just a minute. Alright, let's see how I can get all this into the camera here. So we got your amperage meter right here. It'll be kind of hard to get them both in one take. Let's see. Yeah, right there may work. That's 100 amps. Put it back down. So 100 amps is dropping to 14.7. Oops. Alright, 100 amps is dropping to 14.7. Alright. Let's go up to 200. 200 is 14.6. Pretty accurate too. There's an amp gauge on the actual load tester. Pretty much right there on it. Alright, let's take it up to 250. $14.6 at 250. So far so good. That's right where I was wanting it. Alright, so now we're going to see where it's at 300. Pretty much the 2x12 should not be pulling no more than what we just did right there. It shouldn't even pull that much. It is biased though, so we'll just have to wait and see. But I'm happy to see that it's sitting there. It's 14.6 at 250 amps. That is very, very good. So we'll take it up to 300 now and see what happens. $14.5. Alright, I ain't gonna take it up no higher than that. It will go up around 350, but it begins to drop right after that. See, right where I got it set up for, man, about 14.5 on 300 amps. So there you go, big brother. You could run a 16 pill on this supply if you wanted to, but I definitely only run a Class C 16. I'm AB if you have one. But I put it up to 350 earlier, and it had dropped around 13 volts or so. So right there's good, safe operating. I wouldn't go above 300 amps current with this supply. I want to keep it working, man. I want to keep it good. Don't never push nothing to its absolute maximum. So pretty much for what you're going to be running, you are going to have a little bit of headroom, and that's what you want whenever you're running a power supply, to not be sucking all the juice out of it it possibly can give you just to run a box, you know. So there you go, man. It turned out awesome. Got you some 3-10 for your 220 power cable. And I like this amperage meter, man. Looks just like a bird. I'm gonna stock up on a few of these. I've seen one up to I think 800. They may make them up to 1,000. I'm pretty sure they do, but I like these right here since they match a bird meter. So alright, man, let me get this all hooked up. And I do got some thin wires on here. These are all I had laying around. Yeah, I got to get the L2x12 hooked up with this beast right here so we can show you the this candy apple red setup. Old gatekeeper with this GK 1200. We'll be back. Here she is. Right now, this is the biggest candy painted build I have done as to this date. This is the biggest staged build I have done to this date. And this is the biggest build I've done period to this date. So I've done a lot of biggest with this project. Biggest power supply, biggest candy painted power supply. So this thing's breaking a lot of personal records. This is staged 2x12. So you can run the 2 transistor section by itself, or you can run the 12 transistor section by itself. This is regulated AB biased. Just by looking at this, it looks like these are Class C chokes, don't it? Once you get down here, hang in here with me. This is my second video using my new camera here, thanks to BRB Electronics. If you can see, that is not soldered. That is going straight through the board, straight through the heatsink. All of these bias connections are going straight through the board, straight through the heatsink. And as you can see, I'm going to adjust this strap right here. My hands are a little big. You've got 2 wires coming from the output of each bias circuit. So 2 wires for each of them, except this one back here, which is for the 2 transistor section. Now, how in the world did I do that and still keep these wires protected from the heat of the heatsink? You can't just run wires down through a heatsink and feel good about it. No, you can't. For one thing, this wire right here, I can't remember the type of mil spec wire it is right off the top of my head, but it is about 2 times higher in temp than the normal wire that I use. This stuff was so expensive I could only really afford to buy 50 foot of it. 50 foot of it pretty much cost the same amount as if I bought probably around 300 foot or so of the normal Teflon that I use. So I want to go a little bit higher temp with it. That's one element. The next element is I have it going through Teflon sleeves. Okay, and then after that, I didn't even know they made it till I started looking using the keywords high temp. They actually have high temp heat shrink. I never knew they had that. Basically heat shrink that can handle higher temperature. So it is protected 3 ways. The Teflon itself, the the Teflon sleeving it's going through, and the high temp heat shrink. And I also drilled out, you got a small hole right here for the wire going down, but up under the board the hole is actually drilled out 4 or 5 times bigger. The reason being, I didn't even want this wire to even be touching the heat sink when it goes down. So yeah, that took a little bit of time. So basically the wire in the board itself is tiny, but right up under there you have a hole going through the heat sink. It's about 3 times bigger, so this actually is not even touching the heat sink. So that's called fully protected. I don't feel good about going through wires going through heat sinks first off, but I'll tell you what, to fit all this in this case, if I did not put those wires below the board along with a lot of other wires with the amount of relays that's in this thing, this would be a mess. It would be a mess. It would be a mess. So this did take a lot of time and a lot of planning. The owner of this was more patient than I think any other customer has been. This thing is utilized with 1, 2, 3, 4. I'm still learning this camera. 5 relays. I ain't gonna try to get all super technical with it, but basically the guy wanted a thermal protection switch. Now, I didn't even think about this till I was almost pretty much done with the amplifier. I had to take this board back out of the case when I thought about this, because at first I set the thermal protection switch up for just a 12-pill relay. I didn't even think about the relay for the 2-pill section. So that's why I had to go ahead and add another relay. So both of these relays are tied together to give thermal protection for both of these relays. So if something happened and the ambient air coming out of the heat sink, meaning the actual air itself becomes around 115 degrees. If the air is 115 degrees, the heat sink is a lot hotter. So if that becomes 115 degrees, these relays will kick over. This LED will come on, which is a blue LED, I believe, if I remember correctly. I think it is. And it's very bright for a reason. And then you will not be able to key this amplifier anymore. And yes, I've already tested it out, but there's really no way to test it out right this second. I ain't really got no way to get a torch down here to heat it up, but the thermal switch protection circuit works great, works perfect. It's just a simple switch pretty much with some sophisticated wiring. There's like if I counted right, I think there's like 16 different wire connections hidden under this board. Like I said, if I had all these wires for all these relays on top of the board, it would be a mess. It would be a mess, and it's already crowded, as you can see. I tried my best to make sure no coax overlaps each other. Every coax is the best, the exact length on each side, like these two, and the third one coming over this 4-pill section on the input's the exact length, and the output's the exact length. Every little tiny step of the building process all comes together in the end of a good functional working amplifier. I got lucky and was able to use a doorknob. Sometimes you don't get that lucky, you know, and you don't have the exact value doorknob that you need. But so here is your 2-pill relay right here. This relay is a 3-pole double throw relay. The reason being, this side of the relay right here, let's see if I can't zoom in on it. This side of the relay right here is being used for the 2-pill section. This side of the relay is the bias voltage. Okay, it's the bias voltage going to the 2-pill section. All right, and there's your whole bias section right there. The reason why I am able to use one bias circuit per 4 transistors is because these transistors are perfectly matched. Perfectly matched. And no, I'm not saying perfectly matched from RF parts either. I think I went through, I can't remember now, I think 30 2879s of all the same lot number, 6A's, and I picked and see, I normally wouldn't even have done that. I would have got them from RF parts and just went with it, but since this is a biased box, I just had to go that extra mile to make myself feel better. So that's the way I'm able to get away with that. If I wasn't too sure about that, we would have to have double the amount of resistors right here, and I probably would have went ahead and put them right here, like you see X-Force and BBI and some other guys that utilize biasing, home brewers that utilize biasing. And like I said, it is regulated, so if this thing's ran on a little bit higher voltage, it's not going to affect the bias voltage. Okay, so I think that's about it. Showing all the functions of it. The first switch right here is the 2-pill section. The next switch is the 12-pill section. Your SSB delay switch is back here. Is it going to show it? I gotta get used to this. There it is. There's your SSB switch. Because you got to utilize a SSB delay for both relays. So you got to rock with a double pole, double throw switch for that. Whenever you stage an amplifier, it's more work. It's more wiring. It is, no doubt about it. I love these Russian variables. I have not had one break on me yet. I'm trying to stockpile them as good as I can before they completely disappear. Utilizing the old school Dave made L circuits, or you could call them an LC circuit. Technically they are LC circuit. Alrighty, so let's get this show on the road. Let you see what she's doing. How do I pause this thing? Y'all bear with me. I'm learning how to use this recorder. I got to get acquainted with it. Alright, now I'm pretty sure, you know, this guy's a, you know, pretty big time sideband operator, and I do want to really, you know, let everyone understand this amp's not really designed to be a big mall, you know, big mall hammer high voltage running machine. You know, this thing is designed to be as linear as possible, designed not to be overdriven. It's designed to be a good, clean sounding mall on sideband, or it wouldn't, you know, it wouldn't be, he would not have required a biased amplifier if he wasn't, if that, all this wasn't important to him. So I mean, it's a task to do big bias boxes like this. They do pull a lot of amperage. They pull a lot of more amperage than a Class C. A lot of times you're not going to see as much power because there's a trade-off for linearity. There really is. You can't have the best of both worlds. All right, so 2500 watt slug. Go ahead and show the peak. Let you see what she's doing on the peak end of things. And right about now, I'm really hating with a passion that I let my buddy borrow my 5000 watt slug. I argued with him about it. I said, man, I don't have a backup 5 kW. You ain't gonna be needing it. You ain't got no big boxes coming up, do you? And at the time, I didn't, but I have not got it back from him. Well, anyway, it's all right. 2500 watt slug. Got the peak kit on. Feels kind of weird. I'm holding the mic with the opposite hand than I normally am. Oh, 2500 watts in the Kona. She probably ain't doing a whole lot of bird right now because I really am not driving it very hard. We'll take a look at it. Oh, right there about 1000 birds. So far, just playing around with some different options. I have seen up to about 1300 bird. Just playing around with some different radios. Even my strongest radio, my D-Rail radio, it's even out of service right now. I'm getting some upgrades done to it. I'm going to show the radio working on sideband here in a minute. It's something I don't take time and do a lot of times. I've got a my Superstar right here. I'm gonna hook up and show it working and keying up on sideband and everything. And when I get done and everything, I'm gonna get the top put on it and show the 2-pill section and all that good stuff. I've got the fans unhooked right now because I don't want them sitting there running and blowing on me. It's a little cool out here anyway. So I've got them unsoldered right now. So anyway, man, that is with my hot radio driving into it. Now keep in mind, this is a 2879 2-pill driving into 12, so it's kind of considered what I like to call a mid-drive amplifier, meaning you can drive some power into it. It can take some drive. You see people running 3 pills and 12 pills all the time, etc., but I do want to remind you, just like for example right now, you know, it's probably doing a little bit over 2500 watts, I don't know, but right now I'm showing like around 1000 bird, 2500 watts peak. On sideband, that's rocking and rolling, man. If you would go ahead and throw some more drive into it and get about 3 kW, 3200 or so, you know, you'll be on sideband, so you won't be looking at the bird then. But the person's not going to know it on the other end. You're actually going to sound the best when you're at that mediocre drive level to where you're not driving the heck out of it, because you'll get to this point and you can't see this point without an oscilloscope. An oscilloscope's about the only way you can actually see this. And you can say, okay, I'm going to start driving my amplifier and I'm going to up my drive. I'm going to start real low, up my drive, up my drive, up my drive, until you begin to see distortion coming into play. Then you'll know your limit. But not everybody has an oscilloscope. And I've played around with this thing. It's been fun. I talked on it a little bit during a roll call we had. They do this little roll call thing. I got to key up on a little, let it warm up. The box is not leaving here unless I get to see it warm up and feel it warm up and see that it's still operating. You've got to let a box warm up after it's been built. It is absolutely insane to build an amp and not let it warm up good and test it before you send it out. You're just asking for possible trouble if something ain't correct. You know, it's wasting people's time the way I look at it. But see, I was about to say something, I can't remember what it is now. But man, I love this amplifier. I really don't even want to send it to you, man. I've really been thinking about just heading to Mexico with it, to be honest with you, and just, you know, hitting the border. You hear me say that all the time, don't you? One of these days I'm gonna build me something like this right here, a big sideband maul. You can run the legal limit with this thing right here, man, with ease. With ease. You could run legal limit with this thing all night long, and it wouldn't even break a sweat. That's the way I look at it. But oh yeah, I know what I was going to say. I was playing around a little bit with it with the 2-pill section turned off, and playing around with some different drivers like my 1-pill and certain stuff like that. It's pretty neat, and I was actually able to achieve a little bit more output using an external driver. And see, that's something that you need to keep in mind. You know, when you're running staged amplifiers, you got the RF. Like for example, it's having to leave from here and come down here to the 2-pill driver, leave back up coax, go back up here, come back out of the relay to the 12-pill relay, come back from the 12-pill relay, go back right here to this LC circuit right here, and then, you know, it's a lot of movement, and you have dB loss. Anytime you have to go through other objects, you have to go through more coax, there is going to be dB loss. So that I have always noticed that with staged amplifiers, sometimes you can obtain a little bit higher output using an external driver. It just is what it is. Maybe some of you other builders out there have noticed the same. But yeah, let me go ahead and let me go ahead and get this top put on here, and we'll play around with some other things. Go ahead and try it out on sideband and stuff like that too. I was just wanting you to take a look at the inside. It is a beautiful machine, no doubt about it. Alrighty, we'll be right back. Alright, we got the top put on. I'll bolt it down. There's the front. I like them black grills. I think it sets it off. I think it'd look pretty cool though too if I had some black screws to go on. I thought that'd look pretty nice. This right here is just a case ground. There's a hole there. I thought I'd go ahead and use it up. Like I said, this right here is your thermal protection circuit. You can turn it off or you can leave it on. I would suggest leaving it on. Alrighty. Put the power supply up again. I'll show you the power supply again here in a minute, because I did have to take the top off of it to make a change to it, and also I had to tighten up the bolt on it too. These are the fastest LED fans I have ever been able to find in existence, and they have quit making them, so I am buying them in one color and one color only, and that is white. The only color this company has left, and I have searched the ends of the earth to find other people with these fans, and you can put up to 15 volts of these fans and it will not hurt them. And I mean, they blow as fast as a normal fan that you would put in here, like a normal good medium size, you know, medium speed fan to push enough air for a box like this. But I won't have them forever. So yeah, whenever I do get them, I have to change the LEDs myself. So I had to change all of these LEDs in this particular one. And on the power supply, they still sell ones in red for the ones I put on the power supply. The power supply are low speed fans because I don't really need much air flowing through the power supply. So they still had them in red, but I still used up, I think, 3 or 4 low speed fans that I had here that were blue. So just say, there ain't no reason to buy more fans if you already got some, so I just changed them to red too. So I've changed quite a few LEDs. I had a big pile of LEDs sitting there. Alright, but anyway, I've got the SSB delay. SSB delay. Why do I always make crazy mistakes with my words during my videos? Maybe because it's not scripted. I've got my sideband radio here. Alright. 2500 watt slug. In the corner, just like I thought it would be. That's at least doing 3 kW, I'd say. Beautiful, beautiful. All right, I'm going to unhook this radio now and hook my bench radio up so I can show the input tune and I want to show the input tune and show the 2-pill by itself and show what the 12-pill does on a little bit lower drive and all that good stuff. So let me turn that radio off. Yeah, I thought I could do all this in one hand without pressing stop. There we go. Alrighty. And of course, since it's staged, no matter which one you turn on, they're both the fans are gonna come on. Alright, we ain't on sideband no more. I'm gonna flip that off. Okay. You know what, I am going to have to press stop because I've got to change the coax in the back. Give me 1 second. Alrighty. I'm going to and change the slug to 1000 watts. Alright, let me show you the power flowing through the box with everything turned off. This RF has to go through 2 separate relays, through 2 separate jumpers on the relay, which did require a little bit of correction. So we got the 5-watt slug in reverse. Here is your flow through. Just a micro teensy weensy of a movement. So that is pretty much dead on 50 ohms through the box. Alright, let's turn on the 2-pill section. Variable all the way up. 1000 watt slug. We'll take a look at the RMS. Where the 20 is, that's 200 watts. In between that's 100. So that's hitting right there about 100 watts. And oh yeah. Your amperage meter. I haven't even shown that yet. Heck was I thinking? Got the amperage meter. This is hurting my hands. Hold on, y'all. I'm gonna have to adjust this little strap on this camera. Pretty cool little meter. It's on a pretty long little cord too, so you can kind of put it where you want it. Plugs directly in the back of the power supply. So this is it on just the 2-pill, which ain't gonna be much. That right there is a 500 amp meter. I could not find a 300 or a 400. So we had to roll with that. Alright, so it is doing right there about 100 bird. We're going to roll the variable down just to see what it does. That's about 20 watts, 25 watts. Let's put the variable about halfway. About 50 watts. So you got a little bit of control there. So you can sit there and control that 12-pill pretty good with that variable. let you take a look at the peak. Oh, getting right there about 350, just like an old Texas Star 350. What you think? Just letting this thing go and letting the mop flop. No doubt about it, doing 300, just talking, just like that. Got down, got down, got down, got down. Alrighty. Oh, input tune with the 2-pill on. Oh, yeah. Oh, yeah. Good and low. Good and low. Ooh. Oh, in the corner. Amperage draw. Oh, she's pulling. This is the input tune with the 2 and the 12 on. Go yeah. Go yeah. Go yeah. Beautiful. Beautiful. Alright, let's try out just the 12 by itself. It ain't gonna do much, but 12 by itself. Oh, right there, a little bit under 600 watts peak. Input tune with the 12 by itself. Oh yeah, look at that, good and low. Oh yeah, sweet and low is what I like to call it. Sweet and low. So there you go, man. Boy, I need to take some time and do myself one of these. Alright, let's walk over here to the power supply. Let's take a gander at it. It ain't the most beautifulest thing in the world, but it's just something I put together. Step back, this thing's so long. And there's one thing in here that I've got to give somebody a shout out for. Y'all know me. I'm the GK and I likes to keep it real. I likes to give people credit where credit is needed to be. So I'm gonna go ahead and tell y'all like this right here. I have seen a builder or two, a technician or two. I'm not psychic, I can't 100% say, but I'm pretty sure they possibly may have got an idea from something I've done in the past. Possibly, I can't 100% say. I mean, like I said, I'm not psychic, but I still hear no shout outs or credit given. Not saying I'm looking for one or needing one. It's just something I believe that you do. If there's something that I do completely on my own, completely in my head, that I come out 100% by myself, which is about one of the only things I really can account for is my Y-Mote, my wireless remote. That is about the only thing I've really truly come up with completely by myself without seeing it anywhere else, without getting the idea from something else that I've seen that I made, you know, happen, which is that's nothing super special. It's something I'm using that's already made just for turning amplifiers on. And I mean, yeah, you can say the candy paint, but you know, people's painted boxes before. They may not have done it with candy paint, or maybe not have done it widespread with candy paint, but still, it's just painting a box. There's nothing too special about that. So I mean, it's hard to come up with 100% original ideas in this line of hobby because we're just doing the wheel and we're just trying to make the wheel look prettier or different, but try to make it work the same. But I do have a shout out to give, and this shout out comes from this little thing right here. Can any of y'all guess who I'm about to give a shout out to? Big 100 amp contactor. How else are you going to turn on 10 modules with one switch? You got to have a high powered relay. And where did I first see this relay at? You got it, Mr. Double BI. Mr. Double BI, Mr. BBI. I seen a power supply he built actually in this same exact case, and he was using, I think, this identical relay, except I think it was a double pole instead of, well, I think it was a 4-pole double throw instead of a double pole. You can use either or, as you see. It's strong enough for it. But I had a buddy of mine, which I need to give a shout out to, that actually sent me 2 of these relays. One of the relays I can't use because it's pretty much opposite. These 2 are in normally closed position, and when this goes down they open. It needs to be like this right here, to where they are in the normal open condition, and then when this goes down they close, so they make a connection. And a buddy of mine sent me 2 of them out of nowhere, and I was like, huh, I probably could use this one day. I knew exactly, because as soon as he sent it, I was like, man, I've seen one of them in BBI's video. That's a badass relay. Excuse my language. That's a bad to the bone relay, man. When I looked it up on looked the data sheet up on it, and actually looked and see how much they cost if you bought them brand new, that relay is bad to the bone. That thing will continue to make contact. That thing will not warm up. This thing could turn on probably double, if not triple, of what we're using right here. It's a bad boy. It really is. It's a bad boy. So the way I kind of got away with this not being a 4-pole double throw, and being able to use this for the bus system for the AC plumbing, that's what I got this right here for. So that go ahead and takes the 2 8-gauge 110 wires, 220 wires to this splitter, and that go ahead and splits it up. Now the change I had to make, and one of my mentors that I spoke with on the phone and was kind of bragging about this power supply I put together, which is the biggest one I've done, you know. I'm pretty proud of it. I'm not sitting here bragging, but it's cool to be able to put something together this big, you know, and watch it work and this and that. And he got on to me. He got on to me. He got on to me pretty bad. He's like, gatekeeper, where's your case ground wires, man? Where's your ground wires? Talking about the ground wires to the modules. I'm like, oh, I got them jumped over to the DC ground, man. It's going to the case. Okay, that's fine. It's going to be noisy, though. Somebody ever hooked a radio up to it, ain't going to be able to dang use a radio. It's going to be noisy. And you know what? He was right. I checked it out, and it was noisy. Not only noisy, I could hear my voice I could hear my voice in the modules. So I had to sit here and break this whole box back apart, this whole power supply back apart. It took at least 6 hours a day for me to do this. I had to unscrew the bottom, take them apart, and set up this system here going to the case, and I split it up with each 2 modules. So this right here is 10 gauge wire, comes to there, and I split it up with each 5, got their own 10 going to the case, and it did the trick. Plus I had to tighten up this bolt right here too. I've got that on the insulator, and it was not as tight as it needed to be. And that is the shunt back there, because I didn't have a lot of room to mount this shunt back here like I really wanted to, because of how the width of this shunt right here, that width, a little bit too wide. So I basically put it on a insulator and mounted it that way. And of course that is the shunt for the amperage meter down there. So there you go. It's called current sharing. That's how you make 10 modules work together, and that's something I had to learn. I specifically really had, I'll tell you when I really truly learned about current sharing is messing with these boost converters for the 50 volt equipment. That's when I started learning about current sharing. So let me get this top put on here, and I'll let you take a look at the power supply with the top on. I'll be back. Then we'll be done. Alright, I got the top all on. what I got her set to right there, about 14.9. When you put a good load on it, it should drop around 14.5. The thing's trying to have problems focusing in it. This LED light's kind of throwing it off. Dang. Yeah. Alrighty, bud. I want to thank you for hanging in there with me. This bad boy is going out to Arizona, so it's going to be one heck of a shipping fee, I know that. And I'm telling you, even using switch mode supplies, I mean, this thing's got some weight to it. I can only imagine if this was done with iron core transformers, how much it would weigh. Alright, brother, the only thing I really don't have for you here right now at the very moment is some longer cable. So I'm going to have to let you get that. You know, I don't exactly know how you're going to set this up, how far away the amp's going to be, so I'll let you deal with that. I don't have a lot of extra cable. I need to put in some order and restock up on some power cable. I'm very low right now. But there you go, man. This project broke a lot of records with me. A lot of the biggest records. Alright, buddy. I hope you enjoy. I'm gonna do what I always do after every build right here before I move all these videos over to the computer and merge them. I'm gonna put my hands on both of these devices. And I'm going to pray for them, man. Because that's the last thing I want. Is these things to have to come back to me, have to go to somebody else. I want these things to work the way they were designed. And I want them to stay working the way they were designed. And you can make fun of me all you want. But I am a guy that talks to the big man above. Oh, GK said that. God bless. 73s. I'm going to give a shout out to Jeffro Bodine. I want to give a shout out to, I already gave a shout out to Mr. BBI. I want to give a shout out to Mr. Danny123. He's the one that got on to me about the supplies, which he should know. He's been building these switch mode supplies since before everybody pretty much had accepted them. You can go back and look on YouTube and see he was one of the first ones, or the first one to even start playing around with these switch mode supplies. And I want to appreciate that little bit of information there, because I want these things to be absolutely 100% before they leave. See, this is the first unit, this is the first supply I've done on 220. Now on a 110 supply, the way I did that with the jumper and all that, it'd have been cool. It'd have been completely fine. I've never had a problem with it. I've done it that way. X-Force does it that way. Fat Boy does it that way. But on 220, it's a little different. It's a little different setup. So 73s, old gatekeeper's gone. Bye. On to the next project, y'all. I'm getting there, almost caught up. Then we hitting the big reset button. I'm gone.